Hello and welcome to another Make a Code Monday video. My name is Max. I'm a programmer at the Innisfil Idea Lab and Library. And today I have a fun project to share with you using Makecode Arcade that is all about timers. And so the idea is that we are going to learn how to use custom timers in Makecode Arcade to do things like throttle the rate we can shoot our laser beams, or in this case, our strawberry beams. And so you can see the little meter under my duck recharging, and I can't shoot a strawberry until that meter recharges. And so to make that happen, I make use of some fancy timing features or coding constructs, and that's what I would love to share with you today. And so if you would like to follow along, head to arcade.makecode.com and start a new project. That's what I've done here. I'm right in the middle of a brand new empty project. And so the first thing to do is put a character down so that we can move something on the screen. And so we set my sprite to sprite blank of kind player. That's perfect. Put that in the on start block. I like renaming my characters as soon as possible. I'm planning on this being a duck, so I'm going to call this duck. And I click the gray box, loads up our editor, or we can click on that gallery button and pick a extravagant duck. Perfect. So I press done here. And then of course we want to move our duck around, so move my sprite with buttons, pop that in and change that name to duck. Great. Well, that's just step one. I want to put a character on the screen so that we can demonstrate our other concepts, specifically timers. And so the next thing to do is the simplest implementation of a timer in Makecode Arcade using the game blocks. So under the game drawer, there's on game update and on game update every time of milliseconds. And so 500 milliseconds is the default. So what these blocks do is pretty handy. Every 500 milliseconds, after that time has elapsed, whatever you put in that C-shaped block will happen. And so in the context of the game that you had sort of just seen the demo of, there are evil donuts flying across the screen. So every 500 milliseconds, under the sprites drawer, we can look for our projectiles. Set projectile to projectile from side with Vx, Vy. We're going to use that block to, every 500 milliseconds, make an enemy fly across the screen. And the enemy, of course, is the evil, the dastardly, high carb, high sugar donut. So we pick our donut from the gallery and press done. The way the projectiles work is that whatever velocity x or y you give them will determine what side of the screen they fly from. So with both these numbers being positive, that means it starts from the left and moves down to the right. I want my donuts to fly from the left to the right, so we need a negative velocity, let's say of 70, and then we need no y velocity. So we only want it to move left and right, that's the x value. Smaller numbers mean that they will, I should say that the origin point is 0, 0 on our screen. And so numbers get bigger as you go to the right and bigger as you go down. And then that also means numbers get smaller as you go to the left. So with a negative velocity, we're getting closer to our 0 origin point. And so that's why the donuts start on the right-hand side and move all the way to the left. Some small things we need to change. It's a pretty boring game if the donuts just hang around on the top of the screen. And so under the sprites drawer, we want to set their Y position. Really, we just need this set my sprite block. All the projectiles are sprites, and so we can use this to set their position. And of course, we want their Y position, and perhaps more importantly, we want it to be the projectiles we're working with. Again, I think this is a good opportunity to add some clarity to your code by renaming this variable. I'm going to rename this projectile to donut. Donut. Even better, bad donut. And so our bad donut will start at a particular y position, not at 0. That's the exact same thing as before. But under the math drawer, we're going to pick a random number. So the pick random block will choose a number within a range, inclusive of the two values that are in those little bubbles. And so the height of the screen is 120 pixels. So that's good enough for me. Pick random from 0 to 120 means that our donuts will, yes, stream across the screen. Perfect. The donuts represent our enemies, and so the last thing we'll do for our donuts are under the sprites drawer, we want to go down to the overlaps section and find set my sprite kind to player. Again, we're not interested in my sprite, but we need this block. So set bad donut kind to enemy. That'll make it easier to arrange our code later because our duck also shoots projectiles. I think it's a little cleaner if your duck is the one shooting quote-unquote projectiles that are of the kind projectile, and your donuts are the enemies, even if they start off as projectiles, as you can see in this little blue bubble there. Anyway, so the theme of the day is timers. Here's our first kind of timer. On game update every 500 milliseconds, a donut appears. That's not bad. We can go kind of one further. Under the game drawer, there is a little purple bubble that says time since start milliseconds. This round bubble returns the time since the game started in milliseconds. So the counter starts as soon as the game starts up and just keeps on going up and up and up and up. We can use this counter in a few different ways in order to have timed events in our game. Again, small level of complexity jump, but still pretty simple. We're going to head into the logic drawer and say, if something is true, then I want this middle part to happen. And so I'm going to drag that and encapsulate all of our existing code. And then if true is always true, the word true is always true. And so we need to add a little bit more in there. Back in the logic drawer, we have some comparison blocks. So 0 less than 0, sure. We can put that in there. And this is where we get our fun one. So if the number, let's say 5,000 for 5 seconds, because there's 1,000 milliseconds in a second. So if the number 5,000 is less than the time since we started our game, then we're going to just do what we did. Do what we already did. Else, so if the time since start is greater than 5,000 milliseconds, we're going to do something else. What are we going to do? We're going to add some more projectiles. And then I'm going to put this down here. We're going to add some more projectiles, and these ones will be faster. So negative 120, almost double the previous speed. And so now, in our game, a projectile is going to come no matter what. A donut's going to fly out no matter what. It's either going to be at negative 70 pixels per second or negative 120. No matter what, we're going to set those bad donuts to have a random Y location and set them to the kind enemy. Important for us today, though, is that as the game goes on, the donuts are there. Oh, and they move slower. I see. I'm very sorry. So if 5,000 is greater than the time since start, we'll do that one, else we'll do the other. Yeah, so there's our slow donuts. So once time since start gets larger than 5,000, we see the donuts move faster. And so we can kind of see that play out a little more clearly, because you can tell I was even a little confused. Under the game drawer, on game update, we're going to make our sprite say something. So we scroll down for my sprite say. So we want our duck, this is just for kind of to add some clarity and a little debugging. Our sprite is going to say the current time since the game started. And so now we can see our duck is saying how many milliseconds have passed, and as soon as he says 5,001, the donuts get faster. There we go. So yeah, that makes it a little more clear. So 5,000 is the set threshold. While 5,000 is greater than the time since we started, that means we're going to do this, so slow bad donuts. Else, when the time since we started is larger than 5,000, so this is no longer true, that means our bad donuts are going to get faster. So in kind of these like Space Invader type games, or games like this, like space shooters, that's a pretty common thing, I think, where after a certain threshold in the game, the enemies ramp up in complexity, they get more dangerous, they get faster, and this is one way you can facilitate that type of functionality in your own game. Okay, that was the easy stuff. That was the easy stuff. Let's make it a little more interesting, still sticking with this time since start millisecond bubble. So here, our duck flies around, which is great, but he has no way of fighting back. And so we're going to make some projectiles fly out of our duck whenever we press the A button. So on A button pressed, we are going to find in the sprite drawer the set projectile to projectile of some kind of image from my sprite with a velocity. And so this is a little different than the block we used earlier to make our bad donuts. What's interesting about this one is that Makecode Arcade has kind of done the hard work for us because it automatically makes it come from our sprite. So since it's coming from our sprite, it looks like, we're shooting a laser beam or something. And we're going to fire that off at 90 pixels per second on the X there. And then our picture, so in this game, the kind of narrative of our game is that we have these bad donuts and we're going to fight them off with our very healthy, very delicious strawberries. And so we press done there. And so now there's no overlaps coded in the game, so the donuts won't affect anything, the strawberries won't affect anything. But what I want to illustrate is when you press that A button, you fire a strawberry, that's great. But if you just keep on mashing on that button, you sure do fire a lot of strawberries. And it seems like, to me, that if that's the kind of functionality in your game, it might get too easy too quickly. Because if you can shoot as many strawberries as you want per second, I don't know. I don't think it's going to be very hard for you to get rid of all those donuts. And so what we want to do is add some throttling. We want to make it so that the strawberries that are fired can only be fired at a certain rate whenever you're pressing that A button. And that's kind of the fun part, I think. You'll tell me, I guess. So to do this, we are going to take a snapshot in time using a variable. And our variable will hold in the last time we made a shot. So last shot. We say OK. So we're going to set last shot to 0. It doesn't really matter the first time we do it. Maybe for clarity, we'll just use it the same way all the time. And so last shot is set to the current time in milliseconds at the point that it was assigned. And so once last shot is set to the time since start in milliseconds, the variable itself, called last shot, doesn't change. It's set to whatever time it was when it was created. That's the important part. And that'll come into play next in a logic block. And so when we're firing our strawberries, we can say if something is less than or greater than another. And what we're going to do is some math in there. We're going to subtract some numbers in the logic block itself. And so the diamond here returns a Boolean true or false based on the contents. And so, greater than, less than. What we're doing is we're going to evaluate our last shot as it is subtracted from the time since the start of the game as of right now. And so the last shot is already set. We just set that in the onStart block. The time since start milliseconds is constantly increasing, always going up and up and up and up. And so once we clear, 300 milliseconds, so once the difference between the last time we took a time of last shot compared to the current time, if that number that subtraction, returns a number greater than 300 milliseconds because a minute has passed or because 500 milliseconds has passed. Whatever it takes for the time since start when subtracted from the last time you took a shot to be greater than 300 milliseconds, that's when we'll be able to shoot our strawberry again. If you have a better way to explain that, please let me know. That's the best I can come up with. The whole point is that we took a moment in time, a little snapshot, last shot, and then we subtract that from the current time in milliseconds, which should be a big number if it's been a long period of time, or a small number if it's happened very quickly. And then we use that to determine when we can fire our strawberry. Anyway, let's just take a look. After we do one last thing, of course, we're going to duplicate this because we need to reset that time every time we make a shot, because the last shot variable holds in place whatever time it was we made our last shot. Anyway, let's reset here. So I'm flying around, I'm shooting my strawberry. Oh, I'm sorry, of course, yet again, greater than symbol. So we want this number to be bigger than 300. So here we go, flying around, and there we go. We're shooting our strawberries. If I mash the button, I can't get it to go any faster than that, which is a big difference from before. Of course, if we change that to be, 900 milliseconds, almost a full second, the effect is even more severe. And so I'm shooting my strawberries, and it doesn't matter how fast I press that button. If not enough time has passed, I just can't shoot another strawberry, which I guess is the point. So in your game, of course, maybe you can make like a power-up the player collects, and that time changes. They can shoot their bullets faster, their strawberries faster, or whatever you want to do. That is the main functionality that I wanted to demonstrate. And we can just kick it up one little extra notch, giving our player more feedback in terms of what's happening by including a status bar to show how close they are to being able to fire again. It's like a cooldown meter, you can say. Like once your strawberry is ready to fire again, there's a little visual indicator telling you that you can. And so that, I think, is a kind of fun thing to do. And it's a brand new extension we get to explore. So we click the little gear icon here and head to extensions and scroll down and down and down until we find our status bar. So that'll load up there in due time. And here we go. We have a brand new drawer status bar, which is great. And so the status bar is what it kind of says. It makes a bar that shows a status. And so we want to initialize our status bar. So set status bar to create status bar, sprite width 20 and 20 width for height. And we can say that's energy, which I think makes sense here. I'm going to rename this to maybe be like recharge timer, maybe? I think that's an adequate name. And so set recharge timer to a status bar. We see kind of this little like yellowish bar will be there. Under status bars, we can attach that to another sprite. So attach the recharge timer to my duck. The last thing we're going to do in the onStart block anyway is under status bars, well, I guess two more things. We're going to set the status bar to be 0 when the game starts, because we don't want it to be charged, right immediately for our player. Set that value to 0 on our recharge timer. And then because we want to control, what the maximum is on that status bar, we're going to set status bar value to 0, except change that to maximum. And so here we have 400 milliseconds is the difference we need from the last time we took a shot and the current time. Oh, recharge timer. And so that means we want that to be 400 there, so that those two match conceptually. On game update, we're going to use now to help illustrate to the player what's happening in that status bar. So of course the status bar is empty, nothing really happens. Nothing's really changed about how our game works, just the status bar is there and it is blank. And so the next thing to do is make the status bar meaningful, make that a meaningful recharge timer. And so we're going to head back to status bars and we're going to set our recharge timer variable to be this, to be the time since start minus the last shot. At first, those will be the same number, right? Because the last shot timer is created right at the beginning, and that timer starts right at the beginning. But then as time start gets bigger, and as the difference between them gets larger, our status bar, our recharge timer, will fill up. And so we see it just charge there at the start of the game. And then to make it work as part of our button presses, because that doesn't quite happen yet. Oh, never mind. It already is doing the thing. Right, it already works because the last shot variable is the key. As soon as the last shot variable is reset, so too is our status bar, is our recharge timer. And so there you have it. Our status bar refills to let our player know that they can shoot their strawberry. And that's all good. To round it out as a game, of course, probably the last thing to do would be to add 2 overlaps. And so on sprite of kind player overlaps other sprite of kind player. We need 2 of these. When our player overlaps a enemy, well, that's bad news. We're going to lose a life, which means also we should probably give us some lives. So set life to 3. I'm going to put in our on start. Maybe make that a little easier right now, just while we're testing. Make that 10 lives. So every time you get hit by an enemy, you lose a life, but very importantly, as you've seen there, things happening very quick. We have to also, under the sprites drawer, destroy the enemy. Because if the enemy still exists while it's overlapping us, it's going to keep on triggering this overlap over and over again. And so that other sprite, that enemy, needs to be destroyed, preferably with fire for only 200 milliseconds. Lastly, we want our player to be able to get rid of the bad donuts. So when a sprite of kind, what would we say, projectile, overlaps other sprite of kind, enemy, then same kind of deal. We're going to destroy that other sprite, we're going to destroy that enemy, and also we're going to say our strawberry gets kind of cut up on it and also gets destroyed. And so the sprite bubble here is a placeholder that holds any and all sprites that match the kind, either projectile or kind enemy. In this case, the sprite matches the kind projectile, and the other sprite will hold in all the sprites that are of the kind enemy. Similarly up here, your player sprite is identified by this bubble. Okay, so testing it out, our recharge timer works. We hit those donuts. That's great. So now our game is a little more game-like, and it's a perfect case study for our timers. And so, yeah, the whole crux of it is this idea here, being able to check in on the time since we started and compare that to whenever we last took a snapshot of that time. And so this is an example of a kind of asynchronous way to keep time, because you can have as many of these last shot type variables as you like. You can have a variable that keeps track of the last time you got hit by an enemy, for example, and then maybe like recharge your shield in a similar way, comparing the last time you got hit from the time starting in, subtracting the two, and then, returning some results like a shield recharge, or, anything along those lines. Yeah, and so, of course, just to say, under the info drawer, there is, of course, the start countdown and on countdown end. But as far as I can tell, in the blocks editor anyway, you can only have one countdown. You could use those countdown blocks in a very similar way, but there's only one of them as far as I know, whereas you can make as many of these type of sort of comparisons that you would like. I definitely understand that this was a trickier tutorial than most. It's maybe a bit of an advanced concept using the time since start, or maybe not, if you're comfortable with that kind of thing. Either way, if you would like to review an even more complex version of this game, you can go to github.com/mlupo/idealab_codejams and find the code we used. It's arcade-timers.png on that GitHub repo. And yeah, feel free to download that image file and then just drag and drop that into Makecode Arcade. Anyway, that's all I really had for you today, all I wanted to share. I hope you take the time to try to make your own, I don't know, timer-based game or timer-based functionality in your game, and that you'll share your game with us. Thanks so much for watching, and I'll see you on the next one.